Hello everyone, I hope you are doing fine. Today I'm going to explain the rectifier. A rectifier is used whenever we need to convert alternating current into direct current. This is essential because many electronic devices and systems operate only on DC power. We have three main types of rectifiers. At first, half wave rectifier. As we can see, we have an AC power supply connected with the primary winding. On the other side, we have the secondary winding connected with diode in series, also with the resistive load. Now, if we want to calculate the secondary voltage divided by the primary voltage equal the secondary winding divided by the primary winding by ratio. So the secondary voltage, it will be equal 13.33 volt. Now if we want to calculate the peak voltage, which is equal VRMS multiplied by root 2, and we have VRMS equal 13.33 volt, so it will be 18.85 volt. Now we want to calculate the DC voltage, which is equal V peak divided by pi, which is equal 18.85 divided by pi, which is equal 6 volt. Now if we want to use the second approximation to calculate the DC voltage, which is equal V peak output equal V peak input minus 0.7 volt. 0.7 volt, it comes from the voltage across the diode, which is equal 0.7 volt. Now we substitute the numbers. 18.85 minus 0.7 equal 18.15 volt. That is the peak voltage. Now we will calculate the DC voltage in the second approximation. Peak voltage divided by pi equal 18.15 divided by pi, which is equal 5.77 volt. Also, the input frequency equal the output frequency, and in the example it's given 60 Hz. So the output frequency, it will be 60 Hz. Now if you want to compare between the input voltage signal, I mean the waveform, and the output voltage, as we can see, that is the input voltage signal and that is the output signal voltage. Now we will move to the second type of a rectifier, which is full wave rectifier. The main difference between the previous one, half wave rectifier, and the full wave rectifier is here that we use two diodes. So if we want to calculate from this example the secondary voltage divided by the primary voltage, which is equal the secondary winding divided by the primary winding, so it will be the secondary voltage equal 24 volt. But here there is a difference because we have a center tap at the middle, I mean this center tap. So we should divide this secondary voltage by 2. So it will be equal 12 volt. Also, if we want to calculate the peak voltage, which is equal VRMS multiplied by root 2, it will be equal 12 multiplied by root 2, which is equal 16.97 volt. That is the peak voltage. Now if we want to calculate the DC voltage, which is equal 2 multiplied by peak voltage divided by pi, which is equal 2 multiplied by 16.97 volt divided by pi, which is equal 10.8 volt. Now if we want to use the second approximation, which is equal V peak output equal V peak input minus 0.7 volt. As we said, the 0.7 volt, it comes from the voltage across the diode. So now we will substitute the numbers, which is equal 16.97 volt minus 0.7 volt, which is equal 16.27 volt. Now if we want to calculate the DC voltage, which is equal to multiply by peak voltage divided by pi, which is equal to multiply by 16.27 volt divided by pi equal 10.35 volt. So we will see the difference between the second approximation and the first one. Now if we want to calculate the input frequency, here it's different from the previous one, half wave rectifier. Here we should multiply the input frequency by 2. So we have input frequency in the example 16 Hz. So we should multiply it by 2. It will be equal 2 multiplied by 60, which is equal 120 Hz. Now if we want to see the difference between the input voltage signal and the output voltage signal, as we can see, that's the input voltage signal and that is the output voltage signal. Now we will move to the third part of a rectifier, which is bridge rectifier. Here we use 4 diodes and also the same steps that we used in the half wave rectifier and full wave rectifier, we will use it here. So if we want to calculate the secondary voltage on the secondary winding here, it will be the secondary voltage divided by primary voltage, which is equal the secondary winding divided by primary winding. Now it will be equal the secondary voltage equal 22 volt. Now if we want to calculate the peak voltage, which is equal Vrms multiplied by root 2, it will be 22 multiplied by root 2, which is equal 31.11 volt. Now we will calculate the DC voltage, which is equal to multiply by V peak voltage divided by pi, which is equal to multiply by 31.11 divided by pi, which is equal 19.8 volt. So that is 19.8 volt, which is equal the DC voltage. Now if we want to use the second approximation to calculate the DC voltage, it will be equal V peak output equal V peak input minus 1.4 volt. Here we use 1.4 volt because we multiply by 2 diodes, because it will affect 2 diodes on the V output. I hope you understand the idea. So it will be 31.11 minus 1.4, it will be equal 29.71 volt. So the DC voltage equal 2 multiply by peak voltage divided by pi, which is equal to multiply by 29.71 divided by pi. So it will be equal 18.91. I hope you see the difference between the second approximation and the first one. Now if we want to calculate the input frequency as we use in the previous one, the full wave rectifier, it is the same step. The given frequency in the question, it is 50 Hz. So it will be 2 multiplied by 50 Hz, it will be equal the output frequency 100 Hz. As we can see in the figures, now we will compare between the input voltage and the output voltage. As we can see, that's the input voltage and that is the output voltage. So finally, we understand that the rectifier have 3 main types, which is half wave rectifier and full wave rectifier and bridge rectifier. And the steps, it's the same. Also the strategy when we want to calculate the DC voltage, it's the same, just it's have some different steps, only that. And thank you for listening.